Welcome to LC Insider, your weekly insight into the world of printed electronics, flexible interfaces, and smart design, powered by LC Electronic, the world of printed electronics in one place. Tools for printed electronics designers. In today's episode of LC Insider, we're diving into a practical topic for engineers and designers, the tools you need to work effectively with printed electronics. Printed electronics, often called PE, is becoming more common in home appliances, cars, medical devices, wearables, and smart labels. And for designers, that means one thing: traditional PCB tools are no longer enough. Printed electronics requires a new way of thinking. It's not just about drawing a circuit, it's about combining graphic design tools, CAD software, and production-ready file formats into one process. The goal is less clicking and more control. And today we'll walk you through how to get exactly that. Let's start with the basics. Designing printed electronics is very different from designing classic PCBs. Instead of one board file, you need separate graphic layers, a conductive layer, an insulating layer, maybe a printed graphic layer. Every one of these needs its own file. That means designers need more than one program. Most engineers use a mix of graphic software and CAD tools, a vector editor for functional and graphic layers, a CAD system for shapes, holes, and outlines, and finally, something that exports DXF, PDF, or Gerber files for production. When you understand what each tool is good at, the whole process becomes smoother. Let's talk about the tools themselves. Designing printed electronics is not just drawing lines. Each tool has a specific job, and the magic happens when they work together. When a product has both printed layers and graphic elements, designers must switch between technical and visual thinking. At LC Electronic, many projects begin in Illustrator. Designers sketch functional layers, graphics, and shapes there. Then the project moves into Inventor for mechanical checks. And finally, everything ends up as DXF files, ready for printing. The important thing is that the tools talk to each other. Formats must match, layers must align, and nothing should shift between exports. Here's how different tools fit into the workflow. Illustrator or CorelDRAW are perfect for graphic and functional layers. They give precise control over vectors, curves, and alignment. AutoCAD or Inventor are best for mechanical outlines, cut lines, and elements that need exact dimensions. SolidWorks is great when you need full 3D modeling. For example, housings, snap fits, or areas where flexible parts have to bend. And for hybrid projects that include both printed electronics and classic PCBs, Gerber-based tools like CAM 350 or Altium Designer become essential. The real question is, when should you use each tool? The answer depends on the project stage. During the idea stage, you need speed. Quick sketches in Illustrator, Corel, or even on paper are enough. Dimensions don't need to be perfect. The goal is layout and concept. During the technical stage, it's time to build real files. AutoCAD handles outlines. Illustrator handles layers. You combine everything into PDF or DXF files and double-check that nothing overlaps. During the testing stage, designers print samples on PET, polycarbonate, or other films. After that, they evaluate ink quality, alignment, and flexibility. 3D models from Inventor or SolidWorks help verify if the printed part will actually fit and withstand mechanical stress. Finally, during the production stage, all files must be ready for the factory. That means clean DXF files, a clear checklist, exact layer order, ink names, curing temperatures, and tolerances. At LC Electronic, we integrate all of these files into one master file. If a customer sends Corel files, we check them inside Illustrator and add missing details. If they send Inventor or SolidWorks files, we merge them into a unified DXF that's ready for printing, drying, and cutting. We also add a special technical information layer. This layer contains ink codes like Henkel PE 725A, as well as curing temperatures and times. For example, 130 degrees Celsius for 15 minutes. It includes tolerances and notes. This final file becomes a complete production blueprint. We work with engineers on preparing print layers, optimizing conductive traces, and checking files for common mistakes. This includes fixing wrong shapes, overlaps, or scale mismatches. We don't force designers to work with one specific program. Instead, we adapt to the tools they already use. Let's move toward the conclusion. Working with printed electronics is not about choosing between Illustrator or AutoCAD. It's about asking whether your tools make your work easier or more difficult. The right tools help you design faster, avoid errors, and hand over files that production can use without guesswork. If you want your files checked before production, we can review them for free and give you feedback. At LC Electronic, we combine design knowledge with production know-how, and we're happy to make your work easier. Welcome to LC Insider, your weekly insight into the world of printed electronics, flexible interfaces, and smart design, powered by LC Electronic, the world of printed electronics in one place. This was LC Insider, bridging knowledge and production. Join us next week and see how technology becomes smarter, thinner, and more human.